Hello, this is this is a chapter of the hormone produced by I think I have the longest title, the pancreas, guts, and what and adipose hormones. So at the beginning, I thought I can put it as the metabolic hormones, but I got confused at the thyroid hormone, so I put this long title. And so basically, today in this topic we talk about all the hormone produced by pancreas, guts, small intestine, largely the stomach and small intestine, and the adipose tissues. And the key thing about this is that, which as we mentioned later, almost all the hormones we have mentioned so far, they ultimately, eventually, they are regulated by hypothalamus and the pituitary gland. And in this topic, we talk about everything is none of those are regulated by these two organs. They are regulated by directly by the stimulus, is the stimuli. And we talk first the pancreas. The pancreas is something like this. Is if you open up the abdomen of the human body, it's lie behind the stomach. And the primary about 98% of the pancreas are produced, we call it exocrine tissues, which produce enzymes that to digest the food in the guts, they deliver into the guts. And then about 2% of those, we call it endocrine pancreas. And then has another name, the pancreatic islets. Each islets produce several hormones, and there's the alpha cell produce glucagon, and the beta cell produce insulin, and there's a delta cell produce somatostatin, somatostatin. And so I probably have heard of insulin. What's the function of the insulin? The function of insulin is to decrease blood glucose. How does it do so? How does the insulin decrease the blood glucose? Its function mainly to the muscle cells and adipose tissues to tell them. The insulin tell muscle cells and adipose tissue to uptake glucose. How does insulin to tell muscle cells and adipose tissue to uptake glucose? Here is for example, this is adipose tissue. There's a small transporter called GLUT4. Without insulin, GLUT4 is inside the cells. When there is insulin, this GLUT4 will go all the way up to the cell membrane. And when GLUT4 go all the way up to the cell membrane, glucose will get in. And this is called a GLUT4 translocation. And the GLUT4 is so all the way up to the cell membrane is so powerful. And in some cases, too much insulin actually can cause hypoglycemia, which is very dangerous. And people can fall in coma due to hypoglycemia. And so this is how insulin can reduce the glucose. But another thing is how insulin is regulated. As I mentioned earlier, insulin is regulated not by the pituitary gland or by the hypothalamus. It's directly regulated by the high blood glucose. So when there's a glucose high, This is islet cells. In the center, this is called it K-ATP channel. What is a K-ATP channel? This is a calcium channel that is regulated by ATP. In the situation that the glucose level is low in the blood, the ATP level also decreases in the when the blood glucose is high when the blood glucose is high in the blood, ATP level also increases in the beta cells, and then calcium get out to the cells. ATP channel is open, calcium get out to the cells. When calcium get in, it causes a depolarization. And if you hope you remember what is depolarization. Depolarization not only happen in the neurons, muscles, it also happen in the endocrine cells. The depolarization causing the calcium to get in to the cells. And when calcium get in, insulin get out. So this is the signal, the series signals in the beta cell of how it produces insulin. Overall, you see there's no there's not totally not completely not involved, but a minor effect of the either nervous system or the other hormones from the hypothalamus, hypothalamus or the pituitary gland. And so beta cell produce insulin is the primary hormone that decreases blood glucose. And then the alpha cell that produce the glucagon that is produced by alpha cells. Let's see. Oh, by the way, this also another thing is diseases called diabetes. We believe that we have in the United States more than 10% of people already have diagnosis for diabetes, and about maybe I'm not sure it's more than or just roughly 1/3, more than 10% diabetes, and about 1/3 pre-diabetes. So what caused diabetes? Diabetes is directly related to the islets. So especially islet beta cells. There's a type 1 diabetes, T1D. In the case of type 1 diabetes, the body's immune system, we call autoimmune attack. The body's immune system, for some reason, we don't know yet, just attack the body's own beta cells. And then beta cell loss, people have diabetes. And then for type 2 diabetes, see, at the very beginning for type 2 diabetes is first we call it insulin resistance. What is insulin resistance? This causing the GLUT4 translocation, you need more insulin. You need more insulin to cause the GLUT4 translocation. And then many people with pre-diabetes, this is called pre-diabetes. Many people with insulin resistance, they do not, about like say 70% about insulin resistant patients do not develop type 2 diabetes eventually because there is insulin proliferation, compensatory insulin proliferation. But however, eventually, not insulin, islet proliferation. So islet fail. Islet proliferation fail. Sorry, it's very difficult to write here. When islet proliferation failed, people get type 2 diabetes. There's major type of not only two, but major 2 type of diabetes. And then let's talk about the alpha cell here. Where's mine? Yeah, here. The alpha cell is the primary, the glucagon produced by the alpha cell is the primary hormone to increase blood glucose. And how they do so is very similar to this, but although this KATP channel is open when the ATP inside the alpha cell reduced. Actually, alpha cell and beta cell are very similar to each other. There's one research showing that only one gene can switch the fate from alpha cell to beta cell. I forgot the gene. I think it's AOX or something. But anyway, so say glucagon is the primary hormone to increase the blood glucose. However, how does glucagon increase the blood glucose? It tells the liver to release glycogen into glucose. So its primary function in the liver to release release glucose by degrading the glycogen. And it is different than another hormone we call it cortisol. Cortisol also increases blood glucose, but in the cause of converting amino acids into glucose. That's called gluconeogenesis. And this is called glycogenesis. It's different. And then last one, we have this somatostatin. Somatostatin is block both beta cells and alpha cell. Somatostatin produced by the gamma cells is basically, somatostatin is a general inhibitory hormone. In many cases, somatostatin prevented the happening of depolarization by opening up the chloride channel. So somatostatin not only happen here, somatostatin also produced by the hypothalamus. I believe that. Yeah. Is hypothalamus? Yes, I think so. Yeah. So it's generally an inhibitory hormone. Whenever you go, it prevents depolarization, prevent things to happen. Done by beta cells, the delta cells. Okay, so next, let's talk about another hormone. Let's focus on insulin again. So this is insulin cells. It has KATP channel, and this KATP channel can have the threshold can be affected by other hormones. This is called incretins. 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 What is incretins? Are another group of hormones that can reduce the threshold of KATP, which means when you have a higher incretins, then glucose, then ATP will open to let the calcium out when the glucose level is not that high. And basically, it makes the beta cell more sensitive for the production of insulin. So increase insulin production, that's called incretins. And what kind of hormone is called incretins? GIP and GLP-1. GIP is produced by the K cell in the stomach, and GLP-1 is produced by the L cells in the small intestine. So, in addition to make beta cell more sensitive to high glucose level, GIP and GLP have other meanings. So let's say, as other functions. What's the other function? We'll just keep in mind, and then let's say, how do they produce? When do we have a high glucose in the blood after eating? So after eating, we have a high glucose in the blood. We want the glucose to be removed as soon as possible. And then, what kind of things are motivate? Stimulate the GLP-1, especially GLP-1 production. Food, proteins, amino acids in the small intestine. So small intestine, when they have sent food, the L cells, it promote the LP-1 production. And LP-1 production not only making the beta cell more sensitive to glucose, but also it inhibit the appetite. So this is a major hormone for acute regulation of appetite. And then because of this because of this property, GLP-1 has widely used as a drug. The most famous one is Ozempic, and there's some other drugs, Mounjaro, I think so, by Eli Lilly, many of those. So, and now this drug is one of the best selling drugs nowadays. So overall, how does it work? How does GLP-1 drug works? It works by inhibiting the central nervous system, go away all the way to the hypothalamus to inhibit the appetite. So, and then however, they say this acute appetite regulation is not long-term appetite regulation. What causes long-term? What is the long-term appetite regulation? There's another hormone called leptin. And what kind of organs produce tissue produce leptin? The adipose tissue. Adipose tissue produce leptin, and basically appetite tissue has constitutively produce leptin. Each of those, each single adipocytes produce leptin based on circadian rhythm. And normally in the night, we should have a lower appetite because in the night, adipose tissue produce low leptins. Otherwise, the leptin level in the adipose tissue is not highly regulated, and rather, what regulates the leptin production is the amount of adipose tissue. So, in general, when the body accumulates a lot of adipose tissue inside the body, they supposed to have too much. It's theoretically to have too much hormones being produced. They need to reduce the hormone production. That's the irregular negative feedback pathway. However, we'll see. We have so much obese people nowadays. What happened to them? We don't know. So it's somehow some people call it leptin resistance. And what causes it means they need a higher level leptin to reduce their appetite. However, what caused the leptin resistance? Still not sure. It's probably everything going back all the way to insulin resistance. And what caused insulin resistance? We don't know. So there's so many things we don't know. And let's see. I think that's it. Anything else? Oh, so circadian rhythm regulate leptin, but is I was wrong. Night is high. Okay, this is daytime, nighttime is like this, maybe. Yeah, night is high. So we want to eat more at night. I mean, what? That's all for this section. See you next time.